Hi folks, my name is Daniel Moth, and as you have seen on other content and videos that we have online, Visual Studio 2015 now supports development for multiple platforms, including Android. You can use various programming models in order to develop for Android, and any development story needs to have a debugging story that goes with it. And when you pick your debugging target, you can pick either a device or an emulator. In this video, I'm going to talk about the brand new Visual Studio Emulator for Android. So when we talk to our customers that want to use Visual Studio for Android development and they use emulators that are out there, they give us three pieces of feedback. Number one is that the emulators out there are slow. So we have built a fast x86 image for our Android emulator. The second piece of feedback we hear is that other emulators ask our users to turn off Hyper-V. And developers need Hyper-V for various scenarios, including Windows emulators, but also other development scenarios. So our fast x86 image we load on Hyper-V, so we're definitely Hyper-V compatible. You do not need to turn off Hyper-V just to use the Android emulator. And the third inconvenience for a lot of folks is that there's a separate acquisition story. So there's a separate installation steps, and in some cases, even having to purchase separately the emulator. And our customers think of emulators as part of the development environment. Conceptually, they're together. So with our fast x86 Hyper-V based emulator, you actually get it with Visual Studio. You acquire Visual Studio, install Visual Studio, you now have the emulator. So enough about talking about it. Why don't we go and see it in action in a demo? So here I'm running two instances of Visual Studio 2015. I have one where I did file new project and created this Cordova project. I haven't done anything more to the code. The focus is not going to be on the apps. It's going to be on the actual emulator. And then in this other instance, I just did file new C++ project, and I chose an Android project. Again, I haven't done anything. This code was all there. So you can see up here on the, if I hit F5, it would bind to this menu, and I've got these two options, phone and tablet. Later we'll have more, but for now we have these two. So I've picked phone, and now when I go and hit F5, what that is going to do is going to start the emulator, so it's going to start the desktop application. Here it is. And now the loading is because it's loading that VHD, the hard drive, the image that we've created of Android. So it's loading that on top of Hyper-V. And now you see OS is starting because it's actually booting the Android image from the VHD. So when the Android image boots, you'll see here on the screen, it will just have the Android logo, and then we'll know that we have launched it. And here we go. So if you try this process, for example, with the emulator coming out of the Android SDK, that will take minutes. And here you can see that we get there in seconds, even on this small laptop that I'm using. So now that the emulator started, now you're seeing in the background, Visual Studio is copying, compiling, and deploying the bits. And here is a C++ app that runs. So as you would expect, if I do something here, so I've clicked on it, and there's an event handler in the background, so you see Visual Studio flashing. We've hit that breakpoint, so we are actually debugging against this emulator. But that's not what I'm interested in doing right now, so let's stop that. And then if I go to the Cordova project, same story here. If you go and open the menu, you'll see a few more choices. And the two options at the bottom are the ones that we saw earlier in the C++ project as well. From the other options, do not pick the one that says Android emulator. That is the slow emulator that comes with the SDK. You want to pick the fast one, the one we're giving you over here. So if we go here and hit F5, obviously the emulator is running, so we don't need to run it again. And here the C++ application is running, but what you'll see is the Cordova project is being built. So you see build started. So then deploy is going to happen. Deploy started. And in a minute, we're going to see the splash screen come on top. So here's a splash screen for that Cordova app. It was a blank app, and this is what it says. So you can use various capabilities of the emulator to simulate situations you want to test since you're not running on a real device. For example, you can check here, rotate left. And if I did something like that, you see that we simulate a rotation, and the app behaves well out of the box. Your app may be more complicated, so you'll need to respond to that logic. We'll let you test that. I could continue rotating left, or I can just go and rotate right to bring it up to the same place. And just to show you what I showed you earlier with the C++ one, if I was to try and pause this app by hitting the back button, I had placed a breakpoint here. So we've hit the breakpoint, locals, call stack, everything works just as you would expect. So again, I'm not interested in doing that debugging, so I'm going to stop that and go and focus a bit more on the emulator. So I've shown you launching the emulator and deploying to the emulator from a Cordova project and a C++ project. If you were using Xamarin, you'd be able to use our emulator with that as well. Even if you're using another IDE, you'll be able to use our emulator because we do communicate over the Android Debug Bridge protocol. So for example, here in the console, I've got the ADB devices command, and when I do that, you see it gives us the IP address of our emulator. And if you wanted to verify that IP address, you can go here on the emulator and click on the Tools button, which gives you another flyout with tabs. So here on the Network tab, we can see that for diagnostic purposes, here is the IP address that you see also in the ADB window. Other things that you can do with our emulator is this, for example, accelerometer. You can use that. So you can see the XYZ positions down here. And if you wanted a different starting position, maybe portal flat or landscape or whatever, you can change that and you can see those changing. And that gives you your starting position. Then you can go and hit on the red dot and start rotating this in a three-dimensional grid. So you're simulating moving the device. And if your app was to respond to those movements, you'd be able to test that over here. Also here you can see recorded data such as shake. So if I hit play, nothing is going to shake, but these XYZ things will start going crazy, as you can see. So that is simulating someone shaking the phone, and maybe you want to react to that in your app to refresh the page or whatever. So we can use this to test. We have very rich location simulations as well. So in here, you can go and search and find locations of interest. You can zoom in, move around, and so on. And the reason you would do that on this map is so you can actually go and place a pin. So if I go and click here, we can see this latitude and longitude. That is what we're telling the emulator to behave as if it is there. So your app then would get this notification and you'd be able to test your location aware code. And by clicking again, you've just changed the location again. There's more things you can do here. You can choose pin and then change the seconds per pin, for example, and hit play. And then we go to the first one, and after 2 seconds, move to the second one. So you can simulate paths like that. But if paths is what you want, you can just change to routes, and then you can go and put various pins, and we'll simulate that at various speeds. And now, as it moves around that blue dot, as it changes location, we change the longitude and latitude on the device to be that location without you having to put all those pins along the path. That will just do that for you. So very rich location-aware simulations you can do. And the last tab we see here for now, there's going to be more tabs in the future, is this battery, which allows you to simulate the charge of the battery, whether it is charging or not charging, with this checkbox as well. Let me zoom in here so in the emulator so you can see better the icon at the top. So when I go and increase the battery charge, you'll see that it all becomes white in there. Otherwise, it goes down. So basically, we have real-time simulation of the battery charge, including whether it was charging. Let me zoom back out. Maybe that's too much. So we have this fit the screen button over here. And if I was to go and put this a bit close to it being empty and not charging, then we'll see the Android itself has a dialog with saying, hey, connect the charger. So if something like that happened and it timed out, you could use this power button here to just turn the display on and off. So that's how you can simulate that if that is of interest to you. There are other things that the emulator does that you probably take for granted. So you can type in here from your physical keyboard. If there's audio playing in the emulator, it will come through your computer speakers. So a lot of things you would take for granted and expect, we're meeting your expectations. We're doing all of those as well. So the last thing I want to show you is that if we actually go in here and launch the camera app, you'll see that we have an image that pretends that it is what you're seeing through the camera lens, and you can go and take a picture of that. And when you do that, that is stored on the SD card. So we do not have a UI to interact with the SD card right now, but it is just another VHD, so they are stored over there. So let me go and show you how you can access that if you wanted to now. So I'm just going to close the emulator. So while it is shutting down, here you see Hyper-V Manager. And this is the emulator image that we're just running. So when the emulator goes away, that's going to turn to off. You can also see below the tablet image I didn't show you, and the emulator, the Windows Phone emulator image on top. So when you select this, you can actually go to Settings, and in here you could change the memory configuration of the Android emulator. You could change the number of cores it is using, but also notice how we have two hard drives. One is the VHD with Android itself, and then the other one is that SD card I was talking about. So from here you can get that path. And I've got that path already here. So while the emulator is off, you can just double click here on the SD card VHD, and that means you've mounted it, and now you can go here and browse and see the photos that I've been taking actually with this emulator. So that's a way you can do that. If you do that, remember to eject, otherwise the emulator will not be able to use that the next time you try to start up. And before we go back to the slides, obviously now that the emulator is not running, if I run ADB devices again, it says the list of devices attached are none. So with that, we'll go back to the slide and summarize. So in summary, as you can read on the last bullet, those are some of the capabilities and sensor simulations that I've shown you earlier in the demo. But if you're going to take 3 things away from this, you should take that we are announcing a Visual Studio emulator for Android that is fast, building an x86 image from the Android open source project. It runs on Hyper-V and does not conflict with your other Hyper-V needs. And it comes with Visual Studio, so there's no separate acquisition step required. I'll give you a 4th one, which is it speaks the ADB protocol, which means that if you do want to use our emulator from a different IDE, you're welcome to do so. Now, we really appreciate your feedback, so I'd encourage you to go and search for Visual Studio Emulator for Android. You'll find our blog post, and there we have a survey that I really encourage you to take to give us your feedback on what we should prioritize next. Thank you very much for watching.